Hello, everyone. Today we're going to be learning about nodal analysis. So, nodal analysis is a direct application of Kirchhoff's current law, which states that the sum of the currents both in and out of a node has to equal 0. So, let's get into some examples. For all of these, we're being asked to solve for the voltage at node A, represented as VA. So, let me go ahead and write this node out like so. Okay, and so we've got current going to the left of the node, out and to the right of the node, and out and down. I'm going to draw this as 3 subsequent arrows, and I like to draw all my arrows going out of the node and give them the proper signage based on that. So current going to the left is going to be VA minus 10 volts over the sum of these two resistors, 200 ohms. The current going down is going to be VA over 1,000 ohms. The current going to the right is going to be VA minus 5 over 100. So we sum all this together, must equal 0. Got VA minus 10 over 200 plus VA minus 5 over 100 plus VA over 1,000. We can multiply everything by 1,000 to get that denominator to go away. This one goes away. There's a factor of 5 on the top. This one goes away, and there's a factor of 10 on the top. So we get 0 equals 5 VA. After we distribute everything, we get minus 50 plus 10 VA minus 50 plus VA. We add 100 to both sides, we get 100 equals 5 VA plus 10 VA plus 1 VA gives us 16 VA. Divide both sides by 16. We get VA equals 100 over 16 volts, or approximately 6.25 volts. Okay? Now, if you want, you can take this, plug it back into your nodal equation, and you'll find out that everything does work out to sum to 0. All right, let's look at another example here. Again, solve for the voltage at node A, VA. I'm going to draw my node out here like this, VA. We've got current going down again, current going right, and current going left. So the current going left, again, use Ohm's law, VA minus 10 over 1,100. The current going down is going to be VA over 100. And the current going to the right is going to be minus 3 milliamps. And it's minus because if you look at the circuit, the current is flowing into the node. And since I've drawn this as an arrow going out, I've just got to assign a negative. So we can write this as 0 equals VA minus 10 over 1,100 plus VA over 10 minus 3 milliamps. Add 3 milliamps to both sides. And we get something like this. Now what we can do is we can multiply everything by 1,100. Get this to cancel out, and this should be 100, not 10. So this becomes 33 amps. VA minus 10 plus 11 VA. Add 10 to both sides, we get 43 equals 12 VA. Divide both sides by 12, and we get VA is approximately 3.583. Again, you can plug this into your nodal equation. You'll see that the math does work out. It's just a good way to verify that you are getting the correct answer if you're in like a exam situation. Okay, again, solve for the voltage at node A. I'll draw out my node here, VA. Got current going down, current going right, current going left. Current left is going to be VA minus 3 volts over 100. Current going down is going to be minus 2 milliamps. And current going to the right is going to be VA minus 1 over 1,000. Put this into our nodal equation, and we get VA minus 3 over 100 plus VA minus 1 all over 1,000 minus 2 milliamps. Add 2 milliamps to both sides. You get VA minus 3 over 100 plus VA minus 1 over 1,000. We can multiply everything by 1,000, get this to cancel out, get this to cancel out with a factor of 10 on top, and this becomes 2 amps. So we get 2 amps equals 10 VA minus 30 plus VA minus 1. So we get 11 VA, add 31 to both sides, equals 33 amps. Divide both sides by 11, you get VA of 3 volts. All right, one final example here. Again, same question format. We've got node A here. We're trying to solve for the voltage at this node, represented as VA. We've got current going down, current going left, and current going right. We'll start off with the current going left, which is VA minus 3 over 100 ohms. Current going down is VA over 100. Current going right is going to be VA over 400. All right, put this into our nodal equation like so. We're just summing them all up and setting them equal to 0. All right, now we can multiply everything by 400 here to get this denominator, and this to cancel out. But these leftmost terms will now have a factor of 4 attached to them. So we get 4 VA minus 12 plus 4 VA plus VA. All right, all equal to 0. Add 12 to both sides and we get 9 VA equal to 12. Take 12 divided by 9, which is our VA. And you can simplify this down to 4/3 of a volt for VA.